Good afternoon to one and all. I am R.V. Kiran, Assistant Professor, Department of Mechanical Engineering. Today in this class, I am going to explain you the Kennedy's theorem and a problem on the Kennedy's theorem. And this is my 32nd lecture regarding to the subject kinematics of machinery. So today we are going to see the Kennedy's theorem, that is three centers in a line mechanics. So that is a three centers in line theorem. So it also called as Aron-Holt Kennedy. So generally we used to call it as Kennedy's theorem only. So the Kennedy's theorem generally states that if three bodies moves relatively to each other and they have three instantaneous centers and they lie on a straight line. So these are going to be in a straight line whenever we are going to see this. And locate these type of members. So like locate these three types of bodies. So these three bodies move relatively to each other and they have three instantaneous centers. So in the figure you can see the triangle here. So in this triangle there are three links. So A link, B link and C link, in which it has three instantaneous centers, that is the instantaneous center of AB, instantaneous center of AC and instantaneous center of BC. So these are the three different links, three different instantaneous centers for the links A, B and C. And it has different vectors also, that is velocity of BC and velocity of BC both in the perpendicular direction from the instantaneous center of BC towards a right angled position. So these two links can move. So A is taking as a fixed link here and these two links can move in the either in the clockwise and anti-clockwise direction. Here I am taking the link B moving in the anti-clockwise direction and link C moving in the clockwise direction. So we are considering here three kinematic links, that is movable links A, B and C, which is having a relative plane motion of body. So these three have relative plane motion body to each other. And the number of instantaneous centers is given by. So we have already derived a formula for the instantaneous centers, that is capital N. So these instantaneous centers is taken as capital N is equal to capital N is equal to small n into n minus 1 by 2, that is 3 into 3 minus 1 by 2. It is taken as total 3. So the number of instantaneous centers taken for these triangle is, with the 3 links, is 3 instantaneous centers. The small n is taken as, so here the small n is taken as the number of links, that is 3, where the small n is equal to number of links, that is 3. So the two instantaneous centers at the pin joints of B with A and C with A. So that is, this is the link which is attached to the combination of A link, and B is the link which is attached to the combination of A link. So these are the two links attached, and here we got the two instantaneous centers as I of AB and I of AC. So these are the two instantaneous center positions we have got, and these are the permanent instantaneous centers. So these are to be taken as permanent instantaneous centers. And according to this Kennedy's theorem, the third instantaneous center, that is IBC. So IBC is the third instantaneous center which must lie on the line joining IAB and IAC. So these IAB and IAC is joined by the instantaneous center of BC. So in order to prove this, we are going to take this Kennedy's theorem. So in the earlier classes, we have discussed about this Kennedy's line. So in that we are taking the triangle. So instantaneous center of BC must lie on the line joining IAB and IBC. So in these two sides, so that is the link B and link C, we can move this position to either in the left side or the right side. So according to the our usage, we are going to get the third instantaneous center also in the same line. So in the two centers, that is IAB and IAC line. So either it in the clockwise and anti-clockwise, we are going to move it in any one of the two sides. So that theorem proves if three bodies move relative to each other, they have three instantaneous center and they lie on the straight line. If these are going to move in the clockwise or anti-clockwise direction, this will get the it in the same straight line. That is in the IBC also get in the same straight line, which is on the line to instantaneous center of AB and AC. But instantaneous of BC is a unique point, and hence regardless of whether it will be link B and link C. So either of the link B and link C will move relative to each other. That is, it should have a unique velocity, that is magnitude and direction, and this is possible only when the three instantaneous centers, that is namely IAB, IAC and IBC, are on the same straight line. So that is of the Kennedy's theorem, which we have seen in the last class. So here I have taken this triangle as the example to prove the instantaneous centers for the three lines, that is for the three lines of section. So next we are going to prove this Kennedy's theorem statistically. So now let us consider that the instantaneous center IBC lies outside the three lines, that is the outside the line joining IAB and IAC. So we are going to consider these instantaneous center of the line BC with respect to the other lines also, with respect to the other lines. So the point IBC belongs to the both the links. So here this is the center which is taken from the two links, that is B and C. So this is taken from the both the links B and C, and we are going to consider the IBC is on the first link, that is B. So first of all we are going to consider the point IBC on the first link, that is the B link. So here we are going to take this IBC in the first B link. Its velocity must be perpendicular to the line joining of IAB and IBC. So the velocity of the B link, that is BC, is perpendicular to the line of A and B. Line joining IAB and IBC. Now consider the point IBC on the link C. So now we are taking this link is on the, that is IBC is on the link C. So that is IBC is on the link B. So that is of the two links, that is with respect to B and with respect to C. So then we are considering these two links in the same body, that is IAB and IBC. Next, we have considered two links, that is perpendicular to the links IAC and IBC. Then the velocity on the instantaneous center is same whether it is regarded as the point on the first link or as on the point on the second link. So generally it is to be located on the first link or the second link. So we can take it in the either sides of the two sections. So therefore, the velocity of the point, that is IBC, cannot be perpendicular to both lines, that is IAB and IBC, which is respective to that positions, that is IAC and IBC. So therefore, unless the point IBC, that is instantaneous center of BC, lies on the joining the points IAB and IAC. Therefore, these three instantaneous centers, that is IAB, IAC and IBC, must lie on the same straight line. So they lie on the same straight line, and the exact location of these IBC on the line IAB and IAC depends upon the directions and magnitude of angular velocities of B and C, which is relative to A. So this is relative to A position. So there we can find the 3 points in the same line. So this is the ellipsograph, which is to draw ellipses, and they have three distant centers. So these are the three distance points which is comes under a straight line, and we have taken this as the example of these 3 points. So I am taking these as the example only, not as the reference point. So from the drawing pencil, so this is the location for drawing the pencil, and this is the winding handle to operate that. So the central ring is used to move in the clockwise direction, and by moving these we are going to move this pencil stand also, that is the winding handle is used to operate the device. So whenever you are going to move this winding handle in the clockwise position, the central ring is also going to move that in the clockwise direction. So then we are going to solve a problem on this Kennedy's theorem. So let's see the problem. So in a pin jointed 4-bar mechanism, so a pin is jointed to this 4-bar mechanism with the lengths given directly. So that is AB is equal to 300 mm, BC and CD. So that is these two links has the same length, that is 360 mm, and AD is equal to 600 mm. The length of the angle BAD is 60 degrees. So by this we are going to draw this 4-bar mechanism, and the crank AB rotates uniformly at 100 rpm. So the speed of the AB is given, AB link is given. Locate all the instantaneous centers and find the angular velocity of the link BC. So we are going to find the link BC velocity, that is V of BC. So first of all, from these given lengths, we are going to draw this 4-bar mechanism. In between that, first we are going to take the length AB. So here take the length AB as 300 mm, but the link AD is the fixed one. Here the link AD is the fixed one. So I am taking the AD link as the 600 mm. So that is the fixed link. But remaining three links have the movability. So I am going to take the AD link as the fixed link, which is of the length 600 mm. So that is of 600 mm. So draw the line AD, which is having a length of 600 mm. So take your own suitable scale. So 1:5, 1:10, or 1:20. Then from the point A, take 60 degrees from the anti-clockwise direction to the link AD. So I'm taking the 60 degrees, and to the 60 degrees angle, I'm drawing a line through A, and the length of the line is taken as 300 mm, and the link is positioned as AB, that is 300 mm in length, and having an angle of 60 degrees with the link AD. So that is the fixed link there. So we are going to cut this arc with a compass, that is 300 mm in length. And next we have two lengths, that is 360 mm of the link BC, and CD is also of the same length 360 mm. So from the point B, take 360 mm in the compass and draw an arc. So and draw a long arc. So draw a long arc like this. Then from point D, so then from point D also take 360 mm length in the compass and cut an arc in the previous made arc. So like this. So that is of 360 mm. So we got an intersection point between the lines B and D. So BC and CD. So therefore we got the quadrilateral, and there we got the quadrilateral as shown in the screen. Then I'm going to take the given data. So we have already taken these all links length, and in the question they have given the speed of the link AB, that is NAB is equal to 100 rpm. So N of AB is equal to 100 rpm. So from the speed we are going to find the angular velocity of AB, that is 2 pi n by 60. So 2 into pi into speed of AB is 100 rpm. So by direct substituting we got 10.47 radians per second. So we got in total 10.47 radians per second. radians per second. So therefore the angular velocity of AB is taken as 10.4 radians per second, and since the length of the link AB, that is the taken as crank here, so the length of the crank AB is equal to 300 mm. So this is the crank here, this is the crank observed here. So this is of 300 mm. We are converting it to meters, that is 0.3 mm meters. Therefore, velocity of the point B on the link AB is to be taken. So the velocity of the point B on the link B is taken in that. So here we may also say as follows. We may take by considering these three links, that is 1, 2, and 3. The instantaneous centers will be I12, I23, and I13. So these three are the instantaneous centers with I12, I23, and I13. So the centers I12 and I23 have already been located. So these are already have been located. And similarly, the considering these three links, that is 1, 3, and 4, the instantaneous centers will be I13, I34, and I14. That is I13, I34, and I14. And I14 and I34 have already been located. Thus, we see that the centers I13 lies on the intersection of the lines joining the points I12, I23, and I14, I34. So these are the 4 points of intersection from the 4 links taken, but we are considering only the link's length and the angle of that links only, angle of that crank only with the fixed link. So next we use to find the velocity of the point B. So we have formula from the earlier problems. Also, we have defined this formula from the earlier problems also. Velocity of B is taken as angular velocity of AB into length of the AB. So because here when we are taking this to the B link, so this is the B link here, we have to take the length of A with respect to B position, that is velocity of B with respect to A position. That is why we are taking the length of AB, and that is angular velocity of AB. So angular velocity of AB into length of the AB. So in total we got 10.47 into 0.3. So that is 3.141 meters per second. So in total we got the value 3.141 meters per second. So then we are going to find the location of instantaneous centers. So the instantaneous centers are located as discussed below. Then the first point to be taken is, since the mechanism consists of four links, so these are the four links taken, that is number of 4. Therefore, number of instantaneous center is taken as capital N is equal to N into N minus 1 by 2, that is 4 into N is the 4 links and 4 minus 1 by 2, that is total 6. So in total, 6 instantaneous centers have been located. For a 4-bar mechanism, the bookkeeping table may be drawn as shown in the figure. This is the figure to be drawn on the book. Firstly, you need to draw this quadrilateral with the suitable scale, and then we are going to locate these centers. So already we got 4 centers, that is I12, I14, I34 and I23, and we are going to locate 2 more centers. So for locating the fixed and permanent instantaneous centers by inspection, these centers are taken as I12, I23, I34 and I14. So these four are the instantaneous centers for the fixed and permanent centers. That is the fixed and permanent instantaneous centers to be taken. And now we are going to locate the remaining, that is neither fixed nor permanent instantaneous centers by Kennedy's theorem. So from the Kennedy's theorem, we are going to locate these centers by instantaneous method. That is 3 centers in the same straight line. So locate the remaining neither fixed nor permanent centers by Kennedy's theorem. This is done by a circle diagram as shown in the next 6th diagram. So from this circle diagram, we are going to draw these instantaneous centers by marking all the 4 points equal to the number of links in a mechanism on the circle. So by drawing on the circle, we are going to mark these 4 points equal to number of links in a mechanism. Now we are going to extend these lines. So already in this quadrilateral, it has 2 instantaneous centers. In this line, we are going to locate the center. And in this triangle also, we have 2 centers. We are going to locate these. So from this Kennedy's theorem, we can take any number of 3 centers. That is, in this line you got 1, 2, 3 points, and from this line you got 1, 2, and 3 points, and from this line also we got 1, 2, and 3 points, and from this A point also A, B, and this is 3. So from anywhere we will get the all these 3 points locating in the same manner. That is the same position. Then join the points 1 to 2 and 2 to 3, 3 to 4 and 4 to 1 to indicate the instantaneous centers already in the located program. That is the I12, I23, I34 and I14. These are the already located instantaneous centers. I12, I23, I34 and I14. So from the circle diagram, so you have to draw this circle to any scale and locate these 4 points and join these 4 points from 1 to 2, 2 to 3, 3 to 4 and 4 to 1, and join 1, 2, 3 to form two triangles. That is, this is the diagonal of the rectangle or square formed. So join the points 1 to 3 having the common to both triangles. So these are the both triangles is responsible for completing the two triangles. So these are the two triangles formed with that line. Therefore, the instantaneous center I13 lies on the intersection of the lines joining the point. So they are going to joining the point I12, I23, I34 and I14 as shown in the figure. So thus center I13 is located. So I13 is located as the center of both these two extended lines. So we are going to extend these lines. So this is the side of the link CD and we are going to extend the straight line, and from the line link AB also we are going to extend this line through dotted lines. There from the point of intersection we got a intersection point, that is instantaneous center as I13. So there we got the instantaneous center as the I13. Thus I13 is located, mark number 5, because 4 instantaneous centers have been already located on the dotted line 13. So mark these 5 and the line 13 dotted line. So we are taking the 13 line as the dotted line and marking it as 5. And now join the line 2, 4. So we are joining the second lines also, that is 2 and 4 to complete two triangles. So these are the two opposite triangles formed from the formal one, that is 2, 3, 4 and 1, 2, 4. So these are the two triangles formed by joining the lines 2, 4. Then the side 2, 4 common to both triangles is responsible for completing the two triangles. So they are going to be responsible for completing the two triangles. Therefore, the center I24 is lies on the intersection of the lines joining the points I23, I34 and I12, I14. So these are the intersection lines. I24 is formed between the intersection of the I23 and I34 line and I14 and I12 line, which is shown in the figure. So we have extending these lines. So this is every link we are going to extend this to some extent, and the link sorry, BC also we are going to extend to some extent. So for the extended links, we got the values, and the instantaneous center is found as I24. So the instantaneous center is taken as I24 in position. Thus, center I24 is located, and we are going to mark number 6 on the dotted line, that is 24. So from this dotted line, we are going to mark 6 as the number. Thus, all these 6 instantaneous centers are located. So by locating the I24, we have got all the 6 instantaneous center located to that end. Now we are going to find the angular velocity of BC. So there we are going to find the angular velocity of the link BC. So that is the last proportionate we are going to find out. Let omega of BC, that is angular velocity of BC, is taken as the link BC, that is angular velocity of the link BC. Since B is also a point on the link BC, therefore velocity of the point B on link BC is taken as. So velocity of point B is taken as velocity of B is equal to angular velocity of BC into I13 of B, that is instantaneous center of the 13 position with respect to B point. So we are taking the B point, that is angular linear velocity. Then by measurement, we find that instantaneous center of 13 point into V. So we are taking the length, instantaneous center of V of, that is 500 mm, which is converted into meters, that is 0.5 meters. Next, angular velocity of BC is taken as velocity of B by instantaneous center of 13 into V. So we have already defined the value of velocity of B. Therefore, we are taking the angular velocity of BC. Then it is taken as 3.141 divided by 0.5. So velocity of B by given 3 into B is taken as 3 into 141 divided by 0.5. That is total taken as 6.282 radians per second. So this is the obtained value for the angular velocity of BC. That is the angular velocity of BC in radians per second. So by this, I am ending this class.